Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equations with variable coefficients. So let's get going. Problem. Solve x square into d square y by dx square minus 3x into dy by dx plus y equals to sine of log x by x. See, we are given variable coefficients. Given differential equation x square into d square y by dx square minus 3x into dy by dx plus y equals to sine of log x by x. We know that d is a differential operator with independent variable x and d square is d square by dx square. Now we can write this equation as x square into d square y minus 3x dy plus y equals to sine of log x by x. Now take y common from all the three terms of LHS. We'll get x square d square minus 3xd plus 1 into y equals to sine of log x by x, right? Which is a Cauchy's equation. Now, we'll just reduce this equation to a higher order linear differential equation with constant coefficients by making a simple substitution. Put x equals to e power z, then log x to the base e equals to z for x greater than 0. Let theta be a differential operator with independent variable z and x d equals to theta, x square d square equals to theta of theta minus 1. Now this equation becomes, replace x square d square by theta into theta minus 1 minus 3 into replace xd by theta plus 1 into y equals to sine of replace log x by z by replace x by e power z. Then theta square minus 3 theta plus 1 into y equals to sine z into 1 by e power z. Then this equation becomes theta square minus 3 theta is minus 4 theta plus 1 into y equals to sine z into 1 by e power z is e power minus z, or we can write it as theta square minus 4 theta plus 1 into y equals to e power minus z into sine z, which is a higher order differential equation with constant coefficients, and also this is of operator form, right, which is in operator form. F of theta into y equals to some function of z. Okay, where f of theta equals to theta square minus 4 theta plus 1. Now we need to find the general solution of the given equation, which is given by y equals to yc plus yp. So let's now find yc and yp. The auxiliary equation is f of m equals to 0, where f of m equal to, we have f of theta, theta square minus 4 theta plus 1. Let's replace differential operator theta by m. So that we'll get f of m equals to m square minus 4m plus 1. Then our auxiliary equation becomes m square minus 4m plus 1 equals to 0. Now we need to find the roots. Let's find roots using quadratic formula. M equals to minus b plus or minus square root of b square minus 4ac by 2a. Now compare this equation with quadratic equation in M. We'll get a equals to 1, b equals to minus 4 and c equals to 1. Then M becomes minus of minus 4 plus or minus square root of b square minus 4 whole square minus 4 into a into c by 2 into 1. This becomes 4 plus or minus square root of minus 4 whole square is 16 minus 4 by 2, right? Which is equals to 4 plus or minus square root of 16 minus 4 is 12 by 2 is equals to 4 plus or minus, we can split square root of 12 as 4 into 3, which is equals to 4 plus or minus square root of 4 into square root of 3 by 2. We know that square root of 4 is 2, then we'll get 4 plus or minus 2 into root 3 by 2. Now take 2 common from the numerator, we'll get 2 times 2 plus or minus square root of 3 by 2. 2 gets cancelled and this is equals to 2 plus or minus root 3. Therefore, M equals to 2 plus or minus root 3, which is a pair of conjugate irrational roots. We know that when M equals to A plus or minus square root of B, then YC looks like e power A into Z into one constant into cos h of root B into Z plus B into a constant into sine h of root B into Z. Now our complementary function looks like yc equals to e power 2 into Z into constant into cos h root 3 into Z plus constant into sine h of root 3 into Z. See, we can write this as e power 2z into a cos h into root 3z plus b sine h of root 3z. Now we are having yc in terms of z. We can also write this in terms of x. Okay. For that we need to write e power 2z as e power z whole square into a cos h of root 3z plus b sine h of root 3z. Now replace e power z by x and z by log x. Then we'll get yc equals to x square of a cos h into root 3 log x plus b sine h of root 3 log x, or we know that cos h a z equals to e power a z plus e power minus a z by 2 and sine h a z equals to e power a z minus e power minus a z by 2, right? Then for a equals to root 3, we'll get cos h root 3 z equals to e power root 3 z plus e power minus root 3 z by 2 and sine h of root 3z equals to e power root 3z minus e power minus root 3z by 2. Okay. We can replace cos h root 3z and sin h root 3z. We'll get e power 2z into a into cos h root 3z is e power root 3z plus e power minus root 3z by 2, right? We can also write this as 1 by 2 into e power root 3z plus e power minus root 3z plus b into, replace sin h root 3z by this. We'll get 1 by 2 into e power root 3z minus e power minus root 3z. So we have 1 by 2 in both the terms. So let's take 1 by 2 outside. We'll get a into e power root 3z plus a into e power minus root 3z plus b into e power root 3z minus b into e power minus root 3z. Right? This is equals to 1 by 2 into e power 2z into. Now pick the like terms. A into e power root 3z plus b into e power root 3z. Next go for minus root 3z. We'll get plus a e power minus root 3z minus b into e power minus root 3z. Right? This is equals to 1 by 2 into e power 2z into. Now take e power root 3z common from the first two terms. We'll get a plus b into e power root 3z. Okay. Plus. Here take e power minus root 3z common from the next two terms. Right. Then we'll get a minus b into e power minus root 3z. Now multiply these two terms with 1 by 2. We'll get e power 2z into a plus b into e power root 3z by 2 plus a minus b into e power minus root 3z by 2. Right? You can ask why we have taken 1 by 2 common from the two terms previously. Because in order to reduce the complexity. Okay. Here a plus b is constant and also by 2 is constant. A minus a and b also constant. A minus b also constant and by 2 is also constant. So we can write it as e power 2z into a plus b by 2 into e power root 3z plus a minus b by 2 into e power minus root 3z. Okay, for my convenience, let a plus b by 2, a constant, is equals to c1. We'll represent this whole constant by c1. And a minus b by 2 equals to some c2. Okay, here c1 and c2 are also constant. Then yc becomes e power 2z into c1 e power root 3z plus c2 e power minus root 3z. Now we got yc in terms of z. So let's write it in terms of x. For that, what we have to do? We have to write e power 2z as e power z whole square into c1 e power z whole power root 3 plus c2 e power z whole power minus root 3. Okay. Now replace e power z by x and z by log x. Here we have only e power z, right? So let's replace e power z by x and we'll get y is equals to x square into c1 x power root 3 plus C2 x power minus root 3, which is our required YC. Okay, let's now find YP, particular integral. We'll find particular integral using 1 by f of theta into q of z, RHS part otherwise. 1 by f of theta we are having theta square minus 4 theta plus 1, and q of z is e power minus z into sine z. So this is of 1 by f of theta into e power az into v form. Okay, now compare e power, okay, we need to take e power az towards left by replacing theta with theta plus a. And later we'll operate v with 1 by f of theta plus a. Now compare e power minus z with e power az, then for a equals to minus 1, we'll find theta plus a is equals to theta minus a. Now shift e power minus z towards left by replacing this theta by theta minus a. We'll get theta minus, sorry, this is 1, right? We'll get theta minus 1 whole square minus 4 into theta minus 1 plus 1 into sine z is equals to e power minus z into 1 by expand theta minus 1 whole square. We'll get theta square plus 1 minus 2 ones are 2 into theta is 2 theta minus 4 theta plus 4 plus 1. Minus 4 into minus 1 is plus 1, sorry, plus 4 plus 1 into sine z. Now YP becomes e power minus z into 1 by theta square minus 2 theta minus 4 theta is minus 6 theta plus 1 plus 4 5 plus 1 is 6 into sine z. And here we are having 1 by some function of theta into sine bz form, right? This is of 1 by some function of theta into sine bz form. Now for b equals to 1, find theta square, which is given by minus of b square, which is equals to minus of 1 square is minus 1. Now let's see what happens if we replace theta square by minus 1 in the denominator. The denominator must be non-zero. What happens if the denominator is 0? We'll get e power minus z into 1 by 0 into sine z. Since 1 by 0 is undefined, the total term becomes undefined. Right? Always remember that the denominator must be non-zero. Now take the denominator part. Theta square minus 6 theta plus 6 and replace theta square by minus 1. We'll get minus 1 minus 6 theta plus 6 equals to minus 6 theta. Minus 1 plus 6 is plus 5, which is a non-zero term, right? Now we can replace theta square by minus 1 in the denominator. We'll get e power minus z into 1 by minus 1 minus 6 theta plus 6 into sine z, which is equals to e power minus z into 1 by minus 6 theta plus 5 into sine z, or we can write the denominator as 5 minus 6 theta into sine z is equals to e power minus z into, the denominator we are having minus, right? Just replace this minus with plus, we'll get 5 plus 6 theta. Multiply and divide with, multiply and divide 5 plus 6 theta to this fraction into sine z. Now YP becomes e power minus z into 1 into 5 plus 6 theta is 5 plus 6 theta by 5 plus 6 theta into 5 minus 6 theta into sine z. The denominator is of a plus b into a minus b form, so we can write it as 5 square minus 6 theta whole square into sine z, which is equals to e power minus z into 5 plus 6 theta by 5 square 25 minus 6 square. 36 into theta square into sine z. Again, theta square appears in the denominator. We have to replace theta square by minus 1, keeping in mind that the denominator must be non-zero. Okay, I'll take the denominator part 25 minus 36 theta square and I'll replace theta square by minus 1. I'll get 25 plus 36, right, which is 61. Then yp becomes e power minus z into, this is non-zero, right, 5 plus 6 theta by 25 minus 36 into minus 1 into sine z. Then yp becomes e power minus z into 5 plus 6 theta by 25 plus 36 into sine z, which is equals to e power minus z into 5 plus 6 theta by 61 into sine z. Again, we can write this fraction as 1 by 61 into 5 plus 6 theta into sine z, which is equals to 1 by 61 e power minus z into 5 sine z plus 6 theta of sine z. Theta being differential operator, so we can write theta as d by dz, right? Yp becomes 1 by 61 into e power minus z into 5 sine z plus 6 into derivative of sine z with respect to z is cos z. Now we are having yp in terms of z, but we need to write in terms of x, right? So let's write e power minus z as e power z power minus 1 into 5 sine z plus 6 cos z. Now replace e power z by x and z by log x. We'll get yp equals to 1 by 61 into x inverse into 5 sine of log x plus 6 cos of log x. We know that x power minus 1 is equals to 1 by x power n, then we can write x inverse as 1 by x. We'll get right. Now we can write this as 1 by 61 into x, 61x into 5 sine of log x plus 6 cos of log x. So these are required yp. We got yp and yc. Now let's write the general solution. The general solution is given by y equals to yc plus yp. Then y equals to yc, we have x square into c1 x power root 3 plus c2 x power minus root 3, and yp is 1 by 61x into 5 sine of log x plus 6 cos of log x. This completes the problem. So we have seen a problem from higher order linear differential equations with variable coefficients in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.